Hello, so today we are going to do this problem called assign apartments. And I can describe the problem here. So the problem is that we get n applicants and we get m free apartments, right? And then the goal is to distribute the apartments so that as many applicants as possible will get an apartment. So we have n applicants and then m free apartments, and each applicant has a desired apartment size, right? And so we want to distribute, which means basically give each applicant a free apartment in a way that as many applicants as possible will get an apartment. So we want to optimize that basically. And the constraint here is that each applicant has a desired apartment size, and each of them will accept any apartment, any free apartments that is close enough to his desired size. And the definition of close enough that we have here is that if the applicant desired apartment size is X, the applicants will accept any apartment that is within the range X minus K to X plus K. And K is given as input, right? So overall, the input that we have for this problem is N, which is the number of applicants, and then M, which is the number of free apartments, and then we have K, which is basically just the range window. So it helps us define like what is the acceptable apartment for the applicants. And then we of course also get an array A that represents the applicant's desired apartment size. So A0 would represent the first applicant's apartment desired size. And then we have B, which is the free apartments desired, the free apartment sizes, basically the apartment's real sizes, right? And so how can we do this? But first, let's take a look at an example. So let's say the input we get is N equal to 4, which means we have 4 applicants. We get M equal to 3, which means we have 3 free apartments, and then we get 5, K equal to 5, which means any applicants will accept, if their desired size is X, they will accept any apartments within the range X minus 5 to X plus 5, right? So they will accept something like X minus 5, this range here. Any apartment size that is in this range, they will accept it. Now, if we take a look at this A here, this is the apartment desired sizes for each applicant, and then these are the available apartments. So why is it 2? So we can give this 45, we can't assign it because the allowed range for 45 is just 40 and 50, and we don't have those. Within 40 to 50, we don't have that. So this one won't get anything, right? So this one would not get anything. Let's just say, okay. And then what about 60? 60 we can associate with this one, so we already have 1. And then what about this 60? Well, this 60 can have only 55 or 65, right? We don't have, the only thing we have in that range is this one, and this one is already taken. So we can't assign this one as well. Now, what about 80? Well, 80 can accept within the range 75 to 85. We do have 75, so we have 1. So overall, we can assign the max we can assign is 2, right? So we have this example. Now let's take a look at how we can solve the problem. Okay, so let's see how we can solve this problem. So if we take the example the first example that we had, which is example 1. So that example was that we get A is the apartments desired sizes of the applicants, 60, 45, 80, 60. And then for the apartment sizes, it's 30, 60, 75, right? And we said that one possible optimal solution would be to say, let's give this applicant, the one that has desired size 60. So 30 we can't give it to anyone because it's not within the range of anyone. 45 is the smallest one, its range is 40 and 50, right? So we can't assign 30. So 30 is not helpful. This one we can assign it this one, right? It's the same value, so that's good. This 60 here, after assigning this one, we have nothing to assign it anymore. This 80, the range is 75, 85, so we can assign it this one, so we end up with 2. So if you notice the reasoning that I went through here in my when I was trying to solve this just by hand, I said, okay, when I was looking at 45, I looked at the smallest closest one, which is 30, because if 30 doesn't work for 45, if there was something smaller before 30, that won't work for 45 either. If we had 20 and 30, and then we want to assign for a desired size of 45, and so this one is, the range is 40 to 50. If 30 doesn't work, of course 20 won't work for it because it's smaller, right? And so this is the idea. The other thing is, if we sort the apartment sizes, the desired apartment sizes, right, and sort the, so from this idea basically we get that we can infer something, right, if the sizes were sorted, at least if the apartment sizes were sorted. So let's take a note of that. So let's take a note of that here. So we can infer a useful property if the apartment sizes are sorted. Okay, so let's keep track of that there. Now, is it enough to just sort the apartment sizes? Can we sort the applicant sizes and get some value from that? So if we have, let's say, so if we do 45 first, and then 60, and then 60, and then 80, what this will help us to do is that if a value like 30 doesn't work for 45, we already know that it won't work for 60, so we can skip it, right? So we also get some value of sorting the desired apartment sizes, right? So let's write this down as well. So if the smallest apartment size doesn't work for smaller desired size, right? Desired size, it won't work for the larger one. It won't work for the larger one. Okay, so what this means for us is that if we sort both, we can kind of do a greedy strategy and be able to know when to skip either the apartment size, the apartment, or skip that applicants, because we can't satisfy the requirement, right? And so let's take this example even more like more in detail here, but let's plot it in a way that will make it easier for us to understand. So let's have an axis here for A's, and then let's have one for B's, and have them sorted. So if we have them sorted, that would mean the first one is 45. It has the range 40 and 50. The next one is 60, right, in sorted order. So that would be 60 here, and it's 65, 55, and then we have that twice. So let's just plot the second one below it, 60 and 55, and then we have 80, right? So we have 80 here, which means we have 85 and 75. And then we have the B values. So for the B values, we have first 45, right? If we sort them, of course. Sorry, 30. We have first 30. So we have 30 here, and then we have 60 somewhere here, and then we have 75. Okay. So what is the association that we can do here? So what we can do is, okay, say for 45, we can try the first apartment, the first sorted apartment. We see that it's not within the range, right? So that means this one won't satisfy any other apartments, because as we go to the next apartment, next desired apartment size, since it wasn't satisfied by the smallest one, it won't be by this one, so we can skip this one, right? Which means if we have j as the pointer here and I as the pointer here, that means we can skip it, which means we can increment j, right? And now I will still be here, right? Because we are trying to find a size for this apartment, but we find that the next size is 60, right? So 60 is bigger than 50, so it can't satisfy this one. But since 60 is can't satisfy it, if we go to the next apartment, the size will be bigger, so it won't satisfy it either. So we already know that if we go to the next apartment, it won't be satisfied, so we can't no longer satisfy this one, and so we skip it, right? Which means we do I plus 1. And so we are here. And now let's just codify what condition did we have to skip B, and what condition skip the apartment, and what condition do skip the applicants. So let's write that down. So condition to skip apartment is basically what we found is that 30 is smaller than 40, right? Which means we found that basically B of j is smaller than A of I, right? The apartment size 40, which is minus k, which is just the apartment desired size minus k, the range, right? This is x minus k, this is x plus k, right? And so this is the condition with which we skip the apartment. So the condition is bj is smaller than ai minus k. Okay, so which means if this is the case, what we do is we skip the apartment. Okay, now in what condition do we skip the applicant and move forward, right? So we can see it in this example here, right? What was the condition there? Let me just delete this here. So we found that, okay, 50 is smaller than 60, right? So we know that if we go to the right, we won't find anything that satisfies it anymore. Now what is this? This is just the fact that ai plus k is actually smaller than bj, right? So we know that the next bj would be bigger, and so this will still be smaller, so we won't be able to satisfy it. So that condition is actually just if ai plus k is smaller than bj, then that would mean we need to skip the applicant, which means we need to do I plus plus. Okay. And now let's continue what we were doing here. And so now at 16, we will find that we can actually associate 60 with 60, right? So we do this, right? And so our count, we can increase it by 1. We need to have a counter for how many we can assign. And then we move both pointers. So we do I plus plus and j plus plus to move to the next apartment and to move to the next next applicant and to move to the next apartment, because this apartment now is taken, right? So this is what's the condition for this, right? And so that condition there is if basically here it's exactly the value, but it needs to be just within this range. So the condition there is, let me just do this with, so if it's within the range, which means minus k is smaller or equal to bj, or it's within the range, so basically the range x minus k to x plus k. Okay, now if this is the case, then we need to increase our counter. So let me write it actually in Python style, and then we can move to the next applicant and move to the next apartment, right? which means that now I would be here and j would be here. But we'll find that 65 is smaller than 75, right? Which means that we are in this condition, so we move to the next apartment. So our I is here. We find that it's within the range, and so we count to increase our count by 1, and so now our count will become 2, and we are done, right? Our condition needs to guard for I smaller than the length of A, which is n, and j smaller than the length of B, let's call it m. And so the final result will be that count equal to 2. Okay, so basically this is kind of a greedy strategy where by sorting the arrays we can apply the a greedy heuristic here, saying basically that the main idea is that is these two, right? If let's assign to each applicant in order, right, of desired apartment size, the smallest, let's try to assign them the smallest apartment size available. If that works for them, great, because that will allow us to maximize the chance of the next one to get an apartment size. If that doesn't work, then that apartment is for no good, because we couldn't, it's smaller than the smallest desired size. So as we go to bigger apartment size, it won't be comparable, right? And so that's the main idea there. Okay, so now let's write the code and then let's test it. Okay, so our function here, let's call it assign apartments. And we'll get two things. We will get the array sizes themselves, right? So that would be A, and then B, and then we'll get K, right? And so the first thing we said we need to do is sort both the applicants' apartment sizes and then the apartment sizes, okay? Then the next step would be we need to do the loop here, right, on I and j, and do these conditions. And so to do that, let's have, and we need a counter for the final result that we need to return, right? And so let's do count equal to 0, starts out as 0, and then let's have our 2 pointers that we used here for the applicants and the apartments, right? And so to do that, we need our 2 pointers, so that would be I is equal to 0. Let me do it here like this. So I and j, each of them starts out as 0, right? And then let's have just have something to hold the length, essentially. So this would be the length of A and the length of B. Okay, and then we can start to do our loop. And so our while loop would be while we haven't exceeded applicants and apartment sizes. Okay, and then we can do our check here, which would be if so we would say if basically the other way we can do this actually would be simpler, is instead of doing a while loop, we can just do just have j equal to 0 and then just go through the apartment desired sizes. So that would be the same as going with I. It's pretty simple. And then we need to say we can say if, so that would be our condition here, right? If bg is less than ai minus k, but we need to make sure that j is still valid. So j less than m and a. So our condition here was just that. Let's just take it. copy it, then paste it. Okay. So if j is still within the range and bj is smaller than ai minus k, so this would be just that bj is smaller, right, than ai, which is just a minus k, right? So if that's the case, this is the condition where we need to skip the apartments. So we need to do j plus 1. But we actually don't need to go back to A and to go back to the next apartment. We need to do this while this is the case, right? Because while the apartment that we are examining size is smaller than the smallest desired apartment size range, we need to keep skipping the apartment. So we do a while here, right? And then the next thing would be if it's within if we need to skip the applicants. But skipping the applicants means just going to the next applicant, right? So we can do if the condition we have here, which is if a plus k is smaller than bj, then we can skip, which means just do continue, right? Now, the next one is when it's valid, right? So that would be if a minus k is smaller or equal than bj, and is smaller than or equal a plus k. We of course need to check before that here, let me just write it, to check that j is still within the range. So if j is smaller than m and a minus k is smaller or equal to bj and is smaller than or equal to a plus k. In this case, we can increase the count and we can go to the next apartment, right? So that would be j plus 1, and then with the loop we will go, with the for loop we'll go to the next applicant, right? And that would be pretty much it. The only thing I would say is that we don't actually need to do this continue here, because we can just delete this condition, and then since it won't enter here, it won't enter here, it will just go back and go to the next applicant, right? So that is already simple, right? So this is pretty much the code that we need to do, right? And then, so let's see if we can write what is the time complexity of this. So we definitely know we are sorting. So if we say like the length of A is n and this one is m, then this would be O of n log n, and this would be O of m log m, just sorting, right? And then this here is O of n, just the loop itself, but what's the body of the loop? So in the body of the loop, sometimes we do this while loop that will run at most the size of b, right? And so at most we'll examine each pair, right? Each pair, at most we'd examine each pair, but we will skip either j or skip a, so it's n plus m there as well, right? So that's the time complexity here. In terms of space, what are we using as space? Just the count, so nothing extra. So it's yeah, no space, no extra space used there. Okay, so now let's just write this down and make sure it passes some test cases. Okay, so now let's see it. Let's see how it runs on some examples. So same thing, sorting, and then doing the conditions that we did for skipping, and looking through the desired apartment sizes and keeping account of the ones that we were able to assign, right? And so here we have the first test example that we used, which should be 2, and then I have this example where k is equal to 0, so we need to give the exact size, and so the only one that will satisfy it is 62, which is the same value. And then a more complicated one where the final results need to be 6. We don't need to go into the details of it. You can take a look at it in more details to confirm. And then let's run these and make sure all test cases pass, right? So if we reach this, that means no test case failed here, right? So let's run this and all tests pass. Yeah, so that's it pretty much for this problem. Thanks for watching, and see you on the next